I think hardly anybody understands what it means to be weightless.
With the amount of weight I have gained recently,
I'm
in that camp.
You're standing on Earth.
All right.
I can put you on a scale.
Okay.
And in a traditional scale, it'll have springs. And depending on how much you squeeze the spring,
right,
the meter will tell you how much the little thing.
So I get on it, and the little thing goes up, and it says,
you have weight because Earth is pulling on you, and the ground is pushing back.
Okay.
If the ground were not pushing back, what would happen to you?
You would
fall down through the ground.
Right.
It's the fact that the ground is pushing back that's squeezing that scale. If you are in free fall, you are weightless.
Of course. Okay.
Period.
Right.
You are weightless because gravity is acting on you and there's nothing pushing against you. Isaac Newton knew that objects fall.
Okay.
He's sitting there and he sees the apple fall. It's in free fall.
Right.
Until it hits the ground. Good. So if the apple fell with a scale, the scale would read zero. Okay, then it hit the ground. Then he looks up at the moon and it's floating. And he says, I wonder if the same force that's pulling an apple to the ground is keeping the moon in its orbit. Who thinks this?
How long ago was that? Like 400 years ago?
He would have thought this in the 1660s.
Oh, my God.
Yeah. In his 20s.
Oh,
he's in his 20s.
That's amazing.
Okay? By the way, all evidence shows he died a virgin, so don't be so envious of his circumstances.
I'm envious of his brain, not his genitals.
Okay. Cleared that up. Yeah. All right. He illustrates in a diagram the formation of an orbit. And for me, it's the most brilliant scientific illustration there ever was. Here's how he does it. He draws Earth. At the top, he puts a little mountain.
Okay.
Okay. So now you have like a cannon or some thing that can send a projectile.
Shoots a projectile.
And you spew it out, and it lands at some distance from the cannon. And you give it a little more motion, and it goes a little farther, and even farther, and even farther. And so he's reasoning that if I keep shooting this faster and faster, this cannonball is going to come all the way around the Earth, and there must be a speed where it comes all around, and then I duck, and it keeps going and sustains the path. That would be orbital speed for this cannonball. And if you hit that speed, you don't have to maintain it.